Imagine, just for a second, never having to plug in your electric vehicle again. Like ever. You just get in, drive, and it charges itself. It sounds like something out of a sci-fi movie. Maybe. But the sources we're diving into today suggest you might actually be driving one sooner than you think. Welcome to the Deep Dive. Today, we are taking a really close look at something genuinely revolutionary, the self-charging electric vehicle, or the SCEV. Our mission today is pretty clear. Unpack the, let's say, ambitious vision behind this thing. We're going to explore its energy systems, which sound pretty wild, understand its market goals, and see how it aims to redefine sustainable transport. We've got project charters, technical designs, a whole stack of material. And the core idea here, the thing that really grabs you, is that this SCEV isn't just about tweaking efficiency. No, it's designed, apparently, to achieve a net positive energy balance during normal daily driving. Which means through harvesting energy from different places at once, the car is engineered to continuously charge itself while you're driving it. It's a totally different way of thinking about vehicle power.
That is a bold claim, isn't it? Net positive energy.
So yeah, let's unpack that vision. Because it's not happening in a vacuum. The EV market itself is just, exploding. Our projections show it going from around $388 billion in 2023, potentially $1.7 trillion by 2030. That's a compound annual growth rate of, 23.1%? Numbers like that tell you the world is definitely ready for the next big thing in electric vehicles.
Absolutely. A 23% growth rate. Wow. And so looking at that context, this self-charging idea isn't just some niche experiment. It's being positioned as the kind of next evolutionary step for EVs.
That's right. Our sources suggest this specific market segment, self-charging vehicles, could top $450 billion globally by 2035. And why? Well, it directly hits the two biggest pain points for EV adoption, doesn't it? Range anxiety, that fear of running out of juice, and the current limits of charging infrastructure. Imagine if those just went away. It's a really compelling idea. And when you stack the SCEV's concept against what's out there now, its uniqueness really stands out. I mean, you've got great cars like the Tesla Model S, fantastic range, great supercharger network.
Right.
But minimal self-charging, right?
Right.
Then there's the Mercedes EQS. It offers a solar roof option, but the energy it generates is, pretty small in the grand scheme of things.
It's often quite minimal, yeah.
The BMW iX is loaded with tech, but again, no integrated self-charging to speak of. Lucid Air, incredible range figure, sure, but you still got to plug it in. Even the Lightyear Zero, which was sort of a pioneer in solar integration,
Lightyear.
it faced big hurdles with limited production, very high cost. None of them are really promising total energy autonomy.
So that raises the key question, doesn't it? What is the SCEV actually promising that makes it different? The headline target is, believe it or not, unlimited daily range.
Unlimited.
That's the target. Compare that to the current industry standard of, say, 350 to 500 miles. It also aims for continuous charging during operation, so no more 30 to 60-minute waits at a charging station for your daily needs. And crucially, it's presented as a complete energy autonomy system. The goal is delivering something like 300% higher energy generation potential compared to the nearest competitor's solar roof. And the target price point? Premium, yes. Around $95,000 to $125,000. It's definitely ambitious, a fundamentally different kind of EV.
Unlimited daily range. I keep coming back to that. It's quite a statement.
Oh.
So, okay, how are they planning to pull that off? It sounds like some serious tech involved, not just under the hood, but everywhere. Roof? Wheels?
Exactly. It's multifaceted. Let's start with the most obvious bit, solar power. And we're not talking a tiny sunroof panel here. Think flexible solar arrays really integrated across the roof. Capable of generating 400 watts or potentially more. And designed to blend right into the hood and trunk too. Sleek, not clunky. And this taps directly into what consumers apparently want. Sources say 67% are looking for more energy-independent vehicles.
2/3 of people. That's significant. They want to ditch the pump and the plug.
And it goes way beyond just solar. They're really focused on kinetic energy recovery. So the SCEV plans mention an advanced regenerative braking system. We're talking a 95% energy recovery efficiency when you slow down.
95%. Wow. Think about all that stop-start city driving. That's a lot of energy recouped.
It is, but it goes further. They're integrating these things called wheel hub kinetic energy generators using magnetic levitation tech right there in the wheels to capture motion energy beyond just braking.
Hold on. Magnetic levitation in the wheels. Yeah, okay, that sounds pretty futuristic.
Yeah.
How does that work? How do you generate power from that? And what makes it different from the regenerative braking we already know?
It's a great question. It is pretty ingenious. So instead of normal bearings, which obviously have friction, This system uses magnetic fields to sort of float components within the hub. They spin with almost zero resistance. And that rotational motion is then harnessed using induction. So you're generating electricity with very little energy loss. It basically turns every rotation, even when you're just coasting along, into a tiny power source.
Ah, I see.
Regenerative braking, remember, only captures energy when you slow down. These generators aim to capture energy continuously, just from the wheels turning. It adds another layer of energy capture.
Okay, that's clever. And then there's this other bit that sounds honestly a little wild. Electromagnetic shock absorbers. You're saying they turn bumps in the road into power.
That's the concept. Convert that vertical suspension movement into electrical energy. Think about your commute, potholes, rough patches. They could actually be contributing charge to your battery.
That's amazing.
And what's really neat is the dual function. They can dynamically adapt the damping.
Ah.
So they can maintain or maybe even improve the handling while generating power. We're talking maybe 20 to 200 watts per shock absorber.
Wow.
Yeah, and they have adaptive damping features, like
Mhm.
maybe softening the ride by 10% on smooth roads for comfort, or stiffening up by 30% on really rough roads for better stability. It's constantly balancing energy harvesting with ride quality.
So your suspension gets revenge on potholes by charging your car. I like it.
And the energy harvesting doesn't stop with motion. They're also incorporating thermoelectric generators, TEGs. These are designed to capture waste heat from the drivetrain, motors, even the heating and air conditioning system.
TEGs, thermoelectric generators. Okay, for anyone not familiar, can you quickly break down what that is? How does it turn heat into electricity?
Sure. Basically, a TEG uses something called the Seebeck effect. When you have a temperature difference across two specific types of semiconductor materials, it creates a voltage, an electrical current.
Okay.
So you're grabbing heat that would normally just, disappear into the air from motors, electronics, HVAC, and turning that temperature difference directly into power. It's like finding free energy from the car's own operation.
Right, waste heat recovery.
Exactly. Now, state-of-the-art TEGs might offer, say, 8-12% conversion efficiency. That might not sound huge, but remember, it's harvesting energy that's completely wasted otherwise. It adds up. A single TEG system, the sources suggest, could lead to annual clear savings of 1,500 to 3,000 kilograms per vehicle, and potentially improve battery efficiency by 3-5% just by helping manage its temperature, keeping it in that optimal range.
Okay, now this next one. You mentioned it briefly, but it sounds like the real game changer. Beyond regenerative braking, beyond the wheel hubs, continuous frictionless induction. Power generation from wheel rotation, 2 to the 47, even when just cruising. How is that different from the kinetic generators? And how do you generate power continuously without adding drag?
Yeah, that's an excellent point because this is where that net positive idea really seems to gain traction. So unlike regen braking, which is deceleration only, or the hub generators focusing on harnessing rotational mechanics, this continuous induction system is designed to tap into the inherent electromagnetic forces created by the rotating wheels themselves. But crucially, without imposing noticeable drag or friction, think of it as a constant sort of subtle energy harvesting going on under the car as it moves. The system targets 5 to 15 kilowatts per wheel during normal driving.
Okay, 5 to 15 kilowatts per wheel. So if I'm just driving normally, say, taking the kids to school, what does that actually mean for the battery? Is that enough to, counteract the energy I'm using? Or even add charge in traffic?
That's the critical part. 5 to 15 kilowatts per wheel times 4 wheels. That's a significant continuous power input. For perspective, a typical home appliance might draw 1 or 2 kilowatts. A standard level 2 EV charger might give you 7 to 10 kilowatts. So this system could potentially generate enough power not just to offset consumption in many everyday driving situations, but maybe even provide a net gain, constantly topping up the battery. And during high-speed driving, they're talking peak generation of 50 to 150 kilowatts per wheel.
Whoa.
And the efficiency numbers are impressive, too. 92-96% electromagnetic conversion efficiency cited, with minimal parasitic loss, less than a 1.5% impact on propulsion, apparently. It's incredibly efficient energy generation from motion itself.
It's pretty astounding. So you add all these together, solar, kinetic, shocks, heat, this continuous induction. What's the bottom line for the driver? Financially, practically?
Well, the analysis mentioned in the sources, looking at a comprehensive 4-wheel standard system integrating all this, suggests it could achieve something like an 80-85% overall energy recovery rate, and the projected annual benefits, somewhere between $12,300 and $18,700.
That much.
It's not just the saved electricity costs. It factors in the value of effectively extending your range indefinitely for daily use, plus potentially reduced maintenance from less reliance on plug-in charging hardware. This leads to a projected payback period on the system's cost of just 1.7 to 2.4 years.
Oh, that's quick.
Yeah, it makes it economically very interesting. The sources really frame this as transformational technology, something that could redefine EV efficiency and, potentially eliminate range anxiety altogether. You're not just buying transport, you're investing in something that generates energy.
Okay, but having all these different energy sources flowing in,
Yeah.
solar, motion, heat, that sounds chaotic.
Yeah.
How do you manage all that? How does the car juggle these different inputs?
Right, good point. It's not just about harvesting, it's about intelligent management. The brains behind it all is described as an AI-powered energy optimization system. Using machine learning algorithms, think of it as the conductor of the energy orchestra. It's coordinating all these sources in real time, and it's constantly learning from your driving habits, the weather, how each harvesting system is performing.
So what does that mean for me driving the car? How does that AI actually make the experience better?
It should mean a much smarter, less stressful experience. The AI provides real-time energy balance monitoring, so you always know exactly what's happening with your power levels generation versus consumption. It offers predictive range calculation, but way more accurately than current systems because it's factoring in energy generation, not just use.
Oh.
It uses weather-adaptive charging strategies, so it leverages solar forecasting, maximizing capture on sunny days, adjusting on cloudy ones, and, this is really interesting, route optimization specifically for maximum energy generation.
So my GPS could find the route that charges the car the most.
Potentially, yes.
Right.
Not just the fastest or shortest, but the most energy-productive route. It's constantly thinking ahead to keep you powered up, removing the guesswork.
And looking beyond just driving, this system seems to change the whole relationship with energy, doesn't it? You mentioned vehicle-to-grid, V2G capability.
Yeah.
The car becomes part of your home energy setup, or even the grid.
Yeah. Exactly. That's another huge implication. V2G capability means the SCEV could potentially supply power back to your home.
Right, like a backup battery during an outage.
Precisely. Or just to help manage your home energy costs. But it goes further. It could potentially export significant power back to the grid division. The figures mentioned are 25-30 kilowatts peak power.
That's substantial.
It is. And the financial side is compelling too, potentially generating $1,200 to $2,500 a year in grid revenue. By selling excess power back when demand is high, it genuinely turns the vehicle from just an energy consumer into, well, an energy asset. It contributes back. That's a whole new dimension to sustainable transport.
So this is amazing tech, a transformative vision. But how real is it? What's the actual plan to build and deliver this SCEV? It's not just a drawing board concept, right? There's a timeline.
Oh, yes. Definitely a timeline. It's ambitious, no doubt, but laid out. They're aiming for commercial production within a 24-month window, starting with concept validation, proving the core ideas targeted for February 2026. Then system design freeze by August 2026. Functional prototypes actually demonstrating this energy self-sufficiency are planned for February 2027.
Okay.
Production preparation, setting up manufacturing lines, getting regulatory approvals sorted is aimed for August 2027. Market launch prep by February 2028, leading to the start of commercial production and first customer deliveries by August 2028.
August 2028. So just a few years away if they hit those targets.
It's aggressive, but it's a structured plan.
And underpinning this whole massive effort, there's a set of core values mentioned. Innovation, sustainability, safety integrity, customer focus, quality, collaboration. The list goes on. These aren't just, corporate fluff, are they? They seem tied to actual goals.
They seem to be intended as concrete guides. For instance, quality isn't just a word. It's tied to a target of 99.8% production quality, 0 safety defects. And, get this, targeting a 500,000-plus mile vehicle life.
500,000 miles. And 99.8% quality. That sounds incredibly challenging, especially with so many new integrated systems. What are the biggest hurdles to hitting targets like that? Are they really realistic?
That's a very fair question. And yeah, the complexity is immense. The hurdles are significant. Technologically, it's not just about individual component efficiency solar cells, TEGs. It's about making them all work together reliably for 500,000 miles. Seamless integration and durability are key. Think about constant road vibration. Every connection, every sensor, every harvester needs extreme resilience. That requires testing beyond typical automotive standards.
Makes sense.
Then there's market acceptance. You're asking people to trust a completely new paradigm, never plug in.
Yeah.
Skepticism is natural. So building trust requires more than just marketing. It needs transparent, real-world proof that it works consistently. Early adopter programs will be crucial.
Showing, not just telling.
Exactly. And then regulatory hurdles. Getting safety and environmental certifications, NHTSA, EPA, ISO 26262 for such novel tech is a huge task. Standards for things like wheel hub generators or energy harvesting shocks are still evolving. They'll need to work with regulators.
Right.
And finally, the supply chain. Getting reliable access to specialized components, advanced photovoltaic cells, maybe rare earth elements for the maglev systems, that's always a risk. So, diversification, strategic partnerships are vital. They mention using an agile waterfall hybrid approach in their planning,
Meaning?
meaning they aim for flexibility, quick iterations during development, but within a structured overall path to production, trying to anticipate and build in resilience.
Okay, let's try and quickly wrap up this fascinating deep dive. We've looked at this compelling vision of a car that charges itself continuously, powered by this whole suite of energy harvesting tech. Integrated solar, advanced regenerative braking, kinetic generators using maglev in the wheels.
Those electromagnetic shocks turning bumps into watts.
Right. And the thermoelectric generators capturing waste heat, plus that really innovative continuous frictionless induction from wheel rotation,
All managed by that smart AI system.
turning the car into an autonomous energy producer. And we saw the ambitious roadmap aiming to bring it to market by late 2028.
And maybe this leaves us with a final thought for you, listening. With something like the SCEV, we're not just talking about cleaner cars, we're potentially looking at a fundamental shift in how vehicles relate to energy. What if your car wasn't just for getting around, but actually became a significant contributor, powering your home, maybe even supporting the grid? How would that change your daily life? Your energy bills, our whole collective approach to sustainability. It's a future promising freedom, not just from the gas pump, but maybe from the charging plug too. A whole new meaning for driving energy efficiency.